in this video is randomization and statistics and probability. So randomization and the sampling process is the process of selecting units from a population in such a way that every member has a known non-zero chance of being chosen, with the choice of being driven by chance and not human judgment. It is the backbone of fair, unbiased sampling. So what we're going to do is we're going to give you a sample, a program written in R, and how to conduct randomization. So the first thing that we're going to do is we're going to set our seed. And whenever you set your seed, that means that every time you run the cell, the variables are going to initialize to the same values. And then we're going to create a population. So population becomes our norm, and that's a randomly selected normal distribution, brackets of 10,000 elements with a mean of 50 and a standard deviation of 10. So the true mean becomes the mean of the population. And then we're going to take many random samples and store their means. So sample means becomes numeric of 200. So that means it's a numeric of 200 elements in it. For I in 1 to 200, curly brackets, that's a for loop. Sample I becomes sample brackets population, comma, size equals 100, comma, replace equals false. So that means you're having sampling without replacement. And so what that means is when you sample something and it takes the element out of the sample, you don't replace it with another element. And sample means I becomes mean of sample I. So basically, in your sample means is a variable with 200 elements in it. And so sample means I is going to be the ith element of the sample means. And now what we're going to do, and that was your for loop. So now we're going to print the mean versus the true mean versus the average of sample means. So cat, that's like a print statement, brackets true population mean, and it's going to be your true population mean. And cat, which is your print statement, which mean of 200 sample means. So that's your mean of sample means. And then so your true population mean is 49.97626, and then your mean of 200 sample means is 49.97233. And what that is the mean of the sample means. So now we're going to create a histogram of the values that we just calculated. So hist, bracket, sample means, comma, breaks equals 20, comma, color equals sky blue, comma, main equals distribution of sample means, brackets, random sampling, comma, x lab, that's your label for your x-axis, is sample mean. And then we're going to draw a line, a horizontal line in the histogram. So EB line, brackets, V equals true mean, comma, color equals red, comma, line width equals 3. And then you have a legend, which is a brackets top right, comma, legend equals a vector of true mean, comma, color equals red, it's a vector of red, comma, line width equals 3. So what we've done is we created sampling distribution means in random sampling. So your true mean is going to be 49.975. And then so what we can do here, because this said true mean, so you've got your true mean is 49.97628, and then your mean of 200 samples is 49.97233. But I suspect I could say, oh, well, I'll put another line in there with a different color. But if I put another line in there with a different color, then I think one will just be on top of the other. But we can give it a try. So you're going to have your say color equals green. And then we'll say legend equals true mean. Sample mean, and then we'll say, and we'll give that a try. I suspect it's not going to work the way we want it to work because the true mean and the sample mean are so close. Then what is going to happen is just one line will just overlap the other line. That is what I suspect is going to happen. But we can give it a go. So yeah, so you can see the should be sample. So you can see that the sample mean is 49.97233 and the true mean is 49.97628. And you can see that the sample mean is just overlaid on the true mean because they are just so close together. But I just wanted to show you how you could put a line, a horizontal line with the true mean and the sample mean on it. So that's basically how you perform randomization and sampling, and it gives you an example of how to do that. So that concludes this video. The next series of videos is going to be another statistical topic, but I believe that we have completed our videos on probability and sampling. So thank you very much for watching, and I look forward to making another video for you about statistics and probability very soon.